Okay, so now to find the absolute minimum or maximum over this closed interval, which extreme value theorem guarantees that a continuous function over a closed interval is going to have both, right? Both minimum and maximum. So I'm going to find critical number first to start with, right? So critical numbers, I'm going to take the derivative of function, compute this. So use the power rule here. So bring 2/3 up front. So 3 times 2/3, and then subtract 1 from the power, right? And then minus derivative of 2x is just 2. So it's canceled here. So you get 2 times x to negative 1/3 minus 2. And I'm just going to write this like this. 2 over this minus 2. And then I can just put 1 here and multiply top and bottom by x to 1/3. This will be 2 minus 1/3 over 1/3, right? Now, this is our derivative function, right? So to find a critical number, I'm going to set the bottom to 0 and set the top to 0. So when you set the top to 0, 2 minus 2x to 1/3 equals 0. This will be 2 equal to 2 times x 1/3, and x 1/3 equal 1. And you cube of both sides, so x equals 1. Then take the bottom to 0, which is x to 1/3 equals 0, and take the cube of both sides, so x equals 0. And both of these numbers are in the domain, right? This is in the domain, and 1 is in the domain, so they're both critical numbers. And now I will just make a list of x values here. The x values are going to consist of endpoints of the interval, which is -1 and 1, and the critical number 0. And I already have 1 there, so I'm not going to repeat that. And then here you write the function itself. And the function itself is 3 times x to 2/3 minus 2x. And then we're just going to plug it in and see which one is min, which one is max. So if I plug -1, this is going to be -1 to 2/3 minus 2 times -1, which is going to be, so -1 to 2/3 is just 1. So this will be 3 plus 2, and this is 5. So the value of the function is 5 at that point. And for 1, so I'm going to plug it into the function. So it's 3 times 1 to 2/3 minus 2 times 1, which is 3 minus 2, that's 1. And if you're going to plug 0, then of course for 0 is just going to be 0, right? 0, so you get 0. So the minimum of this y value is going to give me the absolute minimum and max, and the largest of this y value is going to give me the absolute maximum. So therefore -1, 5 has the largest y value. So this is going to be absolute max. And then 0, 0 is the smallest y value. It has the smallest y value. So 0, 0 is going to be absolute minimum. That's